Part A asks us to write down the principal value of tangent inverse negative root 3, leaving our answer in radian. So a ratio of negative root 3 can be obtained from multiple angles, and hence the question asks us only for the principal range. So we ought to know that for this principal range of tangent, all angles must be in between minus pi over 2 and pi over 2. Likewise, you can see it from the trigonometry graph, this tangent graph, tangent x graph. So the principal range, which means that the angle you're supposed to find is supposed to be in between minus pi over 2 and pi over 2. Now, since the ratio is given as a negative ratio, so tangent negative would be in the fourth quadrant. So we usually start the angle here, 0, as a 0 radian. So the answer that we want to find is actually in the fourth quadrant, so it is the negative pi over 2 to 0 region. Now negative root 3, so based on the ratio, this will be negative root 3 because this side is below the x-axis. So over 1, which is the opposite over the adjacent side, since the tangent ratio. So from here we can find a Pythagoras. By Pythagoras theorem, we need to find this hypotenuse side, which is just simply root 3 square minus root 3 square plus 1 square, square root, that gives us 2. And we can easily draw an equilateral triangle if you want, so that you can see that it is actually an equilateral triangle, and the angle that we are looking for is actually pi over 3. Now since this is 0 radians and this is 0 line, so any angle that we move anti-clockwise will be positive, so the angle that we require will be negative because it's moving clockwise. So this is the angle. So tangent inverse negative root 3 is minus root pi over 3. Part B, we're given that sine A is 8 over 17 and A is acute. So we draw a first quadrant triangle, labeling the ratio sine, which is opposite over adjacent, so the angle must always be adjacent to the x-axis. Since this is again starting from 0 degrees or 0 radians, so we moved up the angle. The acute angle is required is here. So the ratio is opposite over hypotenuse, so opposite over hypotenuse. And similarly, by Pythagoras theorem, we can find the last side, 17 square minus 8 square, square root, which gives us 15. Now notice that all sides of the triangle in an acute angle, first quadrant, will all be positive. So the question says the exact value of cosine A, which is the ratio of the adjacent side to the hypotenuse side, so adjacent over hypotenuse, and that's the ratio we want. So that's part 1. Part 2, we're required to find sine half A. Half a factor of half, can be related to the double angle formula. So we can actually check from formula list whether the sine 2a or the cosine 2a would work. Now based on sine 2a, so based on formula sheet, we will see this. Now similarly, we can make the half a, the angle half a, by just taking a factor. So sine a, half factor, 2 sine half a cos a, half a, sorry. Now we wouldn't use this because although this is what we want, we do not have cosine half a. So we will try to look at another one, which is the cosine 2a, or in similar form. So just change the angle by half factor. We are using the sine square. So 1 minus 2 sine square half a to solve this problem. So rearranging, making sine half a the subject, we'll get this. So substituting the ratio of cosine A, which we have got from part 1, 15 over 17, we'll get 1 minus 15 over 17 over 2, which leaves us two answers: the positive square root 1 over 17 or the negative square root 1 over 17. Now as we can see that half a is an angle smaller than a, and since a is already acute, half a must be acute as well. So sine half a must have a positive ratio, so we can simply reject the negative side. And doing some rationalization, so we leave your answer after we have rationalized the denominator. And this will be the answer. Part C, we are told to find this integral, definite integral, by evaluating the answer to 3 significant figures. Now we can see that from formula list, we do not have the direct integral of tangent square. So we have to use trigonometry identity. In this case, we are using the secant square x. So an integral that has a constant outside doesn't affect the answer when you integrate it, so you can just move it outside. So it will become like this: 3 times of pi over 4 from 0 to pi over 4, integrate from 0 to pi over 4. Tangent square, we'll change it simply to secant square minus 1. Now we can integrate secant square x to tangent x. Well, 1 integrate will just simply give us x. So evaluating the definite integral, we will use the pi over 4 first, since it's from 0 to pi over 4. So the answer that gives us for the pi over 4, when you substitute as x minus pi over 4, would subtract the 0 answer. Now since tangent 0 and x equals 0 is still 0, okay, we can just ignore this tangent 0 and 0. Pi over 4 is a special angle as well, so tangent pi over 4 will just leave it as 1. So this makes us 3 times 1 minus 3 pi over 4. So in 3SF, this answer will be 0.644.